Right. Now then, we started out yesterday talking about the greatest common factor. We talked about two methods that we could use. One, I think several of you already would say, hey, I like it better. What methods were we talking about yesterday? What methods, Kagan?
The ladder or whatever.
The factor ladder and
The tree.
the prime factorization. Which one do you like better?
Ladder.
Ladder? Everybody agrees? I do too. I love the ladder, but you have to be able to do both, okay? So that if on a test it says use the ladder, or if in the homework it says use the ladder, you have to do it the ladder method. If it just says what is the GCF, you use whatever method you choose, okay? It's up to you at that point. So, let's go to here. Let's try this one. You have to use, I'm going to say right now, I want you to do a tree. I want you to do the tree for 12 and 56. Isaiah, you already got it done?
No, keep turning it down.
Turn what down?
Whatever that is.
There's something that's really.
Guys, if you give me a minute, maybe I can figure out what it is. Thanks, Isaiah. Yeah, I have no idea where it was coming from, but it's still there. I just, muted it when we didn't have to hear it. So it's still there. I just don't. All right. Prime factor, the number 12. Does anybody have you guys already got 12 done? I mean, it's a pretty easy one, right?
Mm-hmm.
So what does the factor tree look like? Faith.
2 times 6 equals 12. And then 2 times 3 equals 6.
Good. Now, I can write that prime factorization as 2 times 2 times 3 equals 12. All right. Somebody help me with 56. Mr. Gabe. 7 and 8. 7 is prime. 8 is not. So I've got to have another branch come off. Where do I go next, Gabe? 2 is prime. 4 is not. Bring it on. Take it on down. What number multiplied together gives me 4? Kaylee. Callie.
2 and 2.
2 and 2. Remembering, prime factorizations are written in the least to greatest form. So I have 2 times 2 times 2 times 7. Okay. I'm going to marry them up because that all equals 56, right?
Mm-hmm.
These two. These two. Do you agree with me there? Is there anything else that I have in both? A prime factor that's in both? No. But I have a 2, so I've got 2 times 2. The GCF would be 4. Okay? The GCF is 4. By the way, we tried turning the temperature up just 1 degree in here, and we got 3. I set it, I have it set at 70, and it runs 69 to 70 in the classroom. If I set it at 71, it goes to 73 and higher. Yeah, I'm not changing it anymore because I can't handle it like that. 73 is just too hot.
It's fine.
So make sure you bring jackets, okay? Sorry, I can't do it any other way. Okay, so we've done 2 of the trees. We've done a couple of the factor ladders. There is one other method that we haven't done. Nope. And we're going to do it. And it's called the list. So this one's going to be added to your notes. The list method. And we're just going to take those 2 numbers that we just had, which were 56 and 12. Okay? Now, list the factor pairs that go to 12. Well, we know we have 1 and 12, 2 times 6, 3 times 4, right? And I can list them like that if I want to, or I can use them just as pairs. Okay? And those are all the arrangements for 12, correct? I can list the factors of 56. I have 1 and 56,
8 and 7.
2 times
28.
28.
3.
Nope, not 3.
7 times
4,
No.
yes. 4 times 14, isn't it?
Oh yeah.
4 times 14, 5, no, 6, no, 7 and 8. Okay, does that get all of the factor pairs for 56? I've listed them all. Faith,
On 1 times 56, you put 52.
you're right, I did, thank you.
You're welcome.
Not intentionally. Okay, do I have all of the factor pairs for both? Yes. Now looking for the greatest factor that's in both of them. It's right here. Is that what we got when we did the factor tree? We said the GCF was 4, and that's right. So that's the third method that you can use. The only problem with listing is you have to make sure that you go through those rules of divisibility in a order, because if you just start throwing out factor pairs that you just see, you might miss some of them. Okay, some of you threw out the 7 and 8 straight up. That's good, but for me, I have to go down the rules of divisibility to double check things, because we probably would have missed the 4 and 14 and 56. But by using those rules of divisibility in order, we didn't miss them. Okay? So it's just another method. So there are 3 methods. What are the 3 methods that you are now in knowledge of? What are those 3 methods, Brianna?
The ladder, the tree, and the list.
Good. Ladder, we say the tree, but we're actually talking prime factorization. And then the list. We've got 3 different methods. Okay. List factors. Number 1, we're going to do it together. List the factors of 8. How many of you, also when you were doing lists back when you were younger, you would say, well, I got 1 and 8, and I got 2 and 4.
Yep.
And then you'd say, well, here's the pretty rainbow, right?
No.
No.
You guys did it, well, that is one of the ways. They call it the rainbows. I don't
We
do
didn't
that.
the rainbows, but we did do it like
But you did do the list that way. And that's fine if that's the way you want to do your list, as long as you match them all up. Me, I just assume just go 1 and 8, 2 and 4. I'm done there. And over here I've got
6 and 6.
1 and 36. I've got 2 and 18. I've got 3 and 12. I have 4 and 9. Not 5, but 6 and 6. What's the GCF?
2.
The GCF has to be the 4. 2 they have in common, but the biggest, the greatest common factor is right there.
I remember doing this like we used to.
And if you list them, you know, all like what we started a while ago with the 1 and 18 and 2 and 9 and 3 and 6, right? That's all of those for 18? No? What I missed? Okay. And then when we get to 72, we say 1 and 72, 2 and 36, am I right?
Yep.
2 and 36, 3 and 26, is that correct?
No.
No.
Nope. 3 goes into 6, 7.
24.
3 and what?
24.
Thank you. You're right. 3 and 24. Is 4 going to go into it? I've got 4 and,
18.
what'd you say?
18.
18?
18, yeah.
5's not, well, 6, 2 and 3, yes. So I've got 6 and
12.
12?
Yeah.
6 and 12. It is 7, no, 8.
Yeah.
Yep.
8 and 9, correct? That's my other set.
Yeah.
So there's a lot of them in that. And then you would just go back to it and say, oh, well, here's the 9. I'm going to circle it with that 9, yeah, something like that. So now my GCF equals 9. That's a pain. I hate lists. I really do.
Me too.
Remember me telling you could use the ladder
Ladder's
for
the
more than
best.
2? Do you remember me telling you that? Let's do it. We've got 14, 28, and 49. What number do you know will go into all 3 of those? 2.
7.
Nope, 2's not going to go into 49.
7.
7, okay. 7 goes into 14. How many's left over?
2.
Melissa.
What?
How many times does 7 go into 14? Twice. 7 goes into 28. How many times, Brett? 4. Good. 7 goes into 49. How many times, Brian? 7 times. What number will go into 2, 4, and 7?
1.
1. 7 times 1 is 7. That is my GCF of 14, 28, and 49. Do you see why I like the ladder?
Yes.
I'm done. It's over with. This list stuff,
It's kind of it's overdoing.
yeah, it's overkill. I don't like it. But I know how to do it. Okay? I know how to do the prime factorization. I don't have to like it, but I have to know how. Okay? If I did the prime factorization, here would be a thought. If I did the prime factorization and I'm not sure that I'm right, could I go back to doing the ladder and double check it if I wanted to? I sure could. Some people say, well, that's a lot of work. Well, but how important is it to me to get it right? So sometimes that extra work helps me to be successful. Do number 4. We're not going to do all of these. Do number 4, because I'm going to give you time to work. I should have said do number 4 using prime factorization, because that is what it says.
Is that
Yep, you're right. And she's still using it, isn't she? Yeah. Melissa says her sister knows all 3 of them. She's at the high school, what, a senior this year? And she says she uses the ladders. And I know that because I taught her that one, so I'm glad to know that she agreed. They don't have to do it the other way, I'm not doing it. So what should you see? There you go. Good. Okay, you're good so far. Now do your 45. What's your GCF? No, when they get married, they equal one of them. 2 are joined together, they become 1. Really? What is 1, 5? 3 and 45 is 5. If you look at the prime factorization, it is 2 times 2 times 5 equals 20. And for 45, it is 5 times, whoops. It is 3 times 3 times 5 equals 45. These two get together, which equals just the 1 5. Okay, they come together and you count them as 1. So GCF is 5. All right? Because this is the one, honestly, this is probably the tougher of the the tougher of the 3 methods. So let's go ahead and do 32 again with the prime factorization. 32, or number 5, 32 and 90, prime factorize them. Okay? These are prime factorizations. The tree is the tool to get there, but the prime factorization is the way I've written them out. Pardon? I want the prime factorization, the tree this time. I want the factorization done. Okay? You can check it with the ladder if you want, but I want that prime factorization. We will use the prime factorization when we find the LCM, the least common multiple. And you can't use the factor ladder for that. It doesn't work. Not successfully every time, so you just don't do it. I want that one prime factorized. I don't want to see the book out again, okay? Okay, well that's for this one, but then you always have to prime factor that.
Okay.
Takes both of them. I want the trees. I want factor trees. That's not prime. No, divisible by what number? So you gotta bring that down on, add the branch to the tree there.
So I need to go to the left, not the right.
Pardon?
I need to go to the left, not the right.
Doesn't matter, it depends on how you set it up, that's the way to go. Yes. You can start that way. But don't circle them, because neither one of those are prime, so you gotta break it on down. Right. Yes, it would. Now, write your prime factorization in the right order. You got it. Okay, I had somebody ask me, can I start the number 90 knowing 10 times 9? Yeah, you can do it, but you have to know that's not prime. And so you can't draw the fruit until you get those to prime numbers, okay? So here I've got 3 and 3, and I have 2 and 5. Now I've got 2 times 3 times 3 times 5 equals 90. And then on my 32,
We have 2 times 2.
what do we have on 32, Alice?
Amelia.
Amelia, sorry.
2 times 2 times 2
2 times, is it 2 to the 6th then?
5.
2 to the 5th. Wow. What's its greatest common factor? 2. It's the only one that I can put together right there.
Let's get it.
That's it. Okay? How do you feel about finding the greatest common factor now? Fist to 5. Okay? 4.5. I like that. Ignore this one. We're not doing this one. Assignment.
Yes.
So you're going to want to write this in. Math Journal, page 22. And textbook, page 35. Numbers 35 to 39. Okay? 1.5 practice, it's the Math Journal, page 22, and then the textbook, page 35, numbers 35 to 39.
Oh,
Okay.
pages.
35 to 39.
That's 4. Plus what's on the Math Journal, okay?
Are we doing like an and on the?
It's all